This says complete a logic gate circuit for an XOR. Remember the rules when doing logic gates are OR can be just one of them needs to be turned on. Yeah, we should have that at this point. But with exclusive OR, only one can be on at the same time. Alright, so here 0 and 0 with an XOR, alright, is 0. Only one of the switches are on, so that's true. Only one of these switches are on, which is true. Both of these are on, because exclusive means you're only allowed one, alright? Exclusive means you're only allowed to be one, therefore that is false. If it was A or B, okay, then that would have been 0, 1, 1, 1. But because of the X or, it means only one of these are allowed to be valid. Now, the next question says, a red light in a game switches on all of the following, it switches on if all of the conditions are true. Treat these like logic sensors, okay, which is what they are, alright? If D is off, L is on, W is on, alright? So, there are a number of ways to do this, okay? The first one that I'm going to do is probably the most simplest, alright? Because think about it logistically here. If the result of this is true, so if that is on, so you can do this, if that is true, alright, and that is off, you could use an OR there, yeah? So you could use an OR there. The other thing you could do is so you could do an AND with an OR, alright? There's lots of different ways of doing it. You could even not an input and use an AND. So let me just explain this, alright? So remember that, first of all, you've got to remember the rules. Remember with an AND, both need to be true. 1, 1. Otherwise, so remember with an AND gate, so I'm going to just put this here, 1, 0. That's 0. Sorry, I did that wrong there. Yeah? So remember with an AND gate that they both need to be true. Alright? With an OR, it's one or the other. And then you've also got a NOT. So if I did a NOT, that would negate it and change it. Alright? So just remember those rules. So what I'm going to do here is, I'm going to start by knotting D. Because what that does to it is it now makes D true. Because D was off, L was on, and W was on. So I can now combine that with the output of this to get it to turn on. So watch what I can do here. I can do this, this. The outcome of an AND gate, when two are true, is on. So if I've got two ons, I need this to be on. What gate am I going to use based on my rules? An AND. Alright? Now, doesn't mean that your way of doing it is wrong. I'm going to show you some other ways of doing it on the mark scheme. Alright? So, if this was off and this was on, okay, let's follow it. That would have been a 1. That would have been a 1, so therefore the output of that is 1. But then I need to do, so it's just that I've switched the order around and I've joined the AND gate up here instead of here. So now I've got a 1 and a 1, which means the output is 1. Down here we have, this was off, this was on, this was on. This now becomes a 1, and I've joined W up here instead. This one was on, so the output is joined there. So there are multiple ways of using an AND gate to do your solution to this question. Alright? So, let's turn over and look at question 3. Another circuit game will output true if if any two sensors are activated, or if all 3 sensors are activated. This has been represented as a Boolean expression, but there is actually an error. Alright? The expression contains an error. So you've got to break down what is happening here. A circuit in a game will output true if any 2 sensors are activated, or if all 3 sensors are activated. What you're going to do is think about, alright, what the gates mean. What is the annotation? Let's go through what these mean first. We've got a plus, which means we've got a dot, which means and anything above a letter, alright, means, and how do we do exclusive or? Now, what you're going to do is look at this. This says, another circuit in the game will output true if any 2 sensors are activated, or if all 3 sensors are activated. That tells me, alright, it says if any 2 are activated. So looking at this question, what do I need? It says any. Alright, so if any 2 sensors are activated, or if all 3 sensors are activated. So what are we going to need to use? So it says shade 1 that shows the solution with it corrected. Which one do we think it is? It is C, but why?
Because in all scenarios, at least 2 sensors are on.
Yeah. Alright. In all scenarios, it needs 2 sensors on. Okay. And this is, and if you look here, alright, remember it says any 2 sensors, alright? But the only way we can do that is by using an or, alright? If it had said only 1 sensor, you'd be looking somewhere for an exclusive or, because it's being a bit more specific here. But if you look at this one, what gives this away is this is an and, okay? But that means all. Alright, but the question says any. Yeah? So by doing an any, you are going to need 2 ors. You don't even need to understand what's going on inside these. Really, it was this here that fixed it. Because that means I could or all of the sensors. Okay, it's about looking at what the symbols mean and understanding it. Because this here, because of the and or, it changes the outcome. By having 2 ors, it means any can be on. Alright? Now, last thing in this. A green light in the game switches on if all of the conditions are true. Alright? What we've got here, alright, for part 3, is we've got D is off, L is off, and W is on. What it might help you to do in this case, in this way, is it says write the Boolean expression, and you must use the Boolean expression operators in your answer. I would personally think about drawing a gate to do this, because it says D must be off, L must be off, and W must be on. So what I might do, if that starts off as off, I might turn it on, and I might turn that on, and combine it with this. And combine it with the W. Because that's already on. So if I put a not there, and put a not there, alright, that now means that that is on. So I can put the 2 nots into an AND gate if I want, and the outcome becomes 1. And I can put an AND gate here at the end of this with the 1, and the output is 1. So think about if you can draw it roughly and work out what it does, it's going to make your expression easier to do. Because all I then do is put a not D and not L and join it to W. Some of you may have wrote that slightly different. Some of you may have written it this way. W and not alright, some of you may have done it that way by using a or, because whatever is put in, it's off. Alright, so that's the other way you probably could have done it as well is you could have put not D and W, because that means, alright, not L. That's another way you could have written it, because then what's happening here is when we not that would be a 1 and 1, which gives me true. And if I'd not that L, that gives me a 1 and a 1. So those together are going to make true. Okay? So that's the second part of that.